Welcome everybody to the recap of week 2 for the DiscoBots. Um, we made a lot of good progress yesterday on Saturday. I think we had great turnout. A lot of people, 20 something plus people. So excellent stuff. I'm going to share my screen, a little bit of the slides, and then we'll let other people take over here as we get going. So you should be able to see, let me move this window over a second here. So you should be able to see kind of my slides here. Let me know if you can't see it. This is a little bit redundant from what we've done in the past, but I like to kind of get into schedules. So Lamar didn't really meet Friday, but they did do their Tuesday, Thursday, and then of course we did a big meeting on Saturday at Lamar. West Side, are you guys on a regular schedule yet, or what's kind of the schedule?
Yeah, we're going to stick with Tuesdays and Thursdays as we are so far, like we've done before.
Okay, Tuesdays and Thursdays. All right.
Yes.
And then I know Carnegie told me they're doing Wednesdays. I've been told they haven't really been doing much FRC, so I'm going to try to follow up and see if we can get them going more and getting more involved. And then DeBakey was actually at one of the build meetings on Thursday. They just were heavily working on Vex, trying to get ready for a competition they went to yesterday. So. Sub-team wise, I think this is a good time to start updating names. So Adrian and Kyle, and there's probably a few other names. Definitely we're doing programming and have their environment set up. CAD wise, we had a lot of people. I don't know if I can do all the names right now. Greg, Sid, Sawmill, Cedric, and we need to update this list and really try to divide tasks between all the people that are CAD able and programming able, because it might seem like we have quite a few, but when it gets down to people that have actually had a lot of experience, it's going to be a pretty small list. So we need to make sure each of those people have things to do and isn't feeling like they're bored. And then everybody else, like all the other people, will be building stuff. All other non-CAD programmers. And so there's a lot of people on this list, and same deal. We need to have a little more direction on who is building what. So for instance, we were building the rev modules, and there was this is the rev swerve modules that were being built on Saturday, and a very important thing to do. I know Carl was kind of overseeing some of it, but we had a few students that were learning the ropes, and we don't want somebody to just say, oh, I want to start building rev modules. We want somebody who has some experience kind of watching over it, because they can be tricky and there's a lot of things that are going to get more complicated and we kind of need to help and delegate. So but eventually we'll need to have this on a roster, and we'll maybe update this a little bit so everyone has more definition of what the roles are. Slack channels, we talked about this before, but I think we're doing a pretty good job. We have lots of channels making progress, and we just probably need more new people on there talking and asking questions. So don't feel shy. Open Alliance, we've made a few updates. Now we're working on week 2 updates. And I don't think we've got a lot from Lamar, so Sawmill and maybe some other people think about stuff you guys can update on what you've been doing at Lamar, so we can kind of stay on top of it, lose track. And then awards are coming up real quickly, so we have to get those essays in and start thinking about that. So that's still on the radar. A lot of stuff to do. I don't think this to-do list is complete, so maybe we'll just kind of bypass some of it. And yeah, I think this kind of goes back to the topic of how we divide the task. One thing that we did just decide on is kind of a ground intake, but now we have to decide on a bunch of other things. We did do some intake testing. If you didn't see those videos, those were pretty promising. Everyone's pretty happy with that. So we got a lot more work to do here, and I think we can flesh this to do this out better. But let's just get into, I guess, kind of the strategy CAD discussion um, of what we want to do. I think I'd like to start off with Sawmill, talking about ground intake, and then we'll kind of get into more complicated mechanisms beyond that. And then maybe the drive, yeah, so we'll do Sawmill, and then we'll do Drivetrain, and then we'll go into kind of Sid's going to talk about the overall hierarchy of the CAD. And if somebody else wants to chime in, just let me know. I'll let those guys take it.
All right then. So if you followed on Slack, you will notice that a while back, sometime during last week, I think Thursday, Lamar, we had posted the CAD of an integrated intake and flywheel mechanism that would copy kind of the Quokka's design and do that. But on the Saturday meeting, we have decided against an integrated intake and shooter, and instead are going for two separate subsystems. So we will, first of all, one of the major decisions is that we have decided it will be under bumper. So just like Spectrum and a lot of other good teams are doing, our intake will be within our robot's frame perimeter in order to make sure that it has virtually very low chances of getting destroyed by interactions with the field. Then the other decision was splitting up the subsystems of shooting and intake. So that means the ground intake will be stationary towards the front of the robot. And of course, it will be under the bumper. So it won't be articulated. It'll just be some tubes that spin really fast and try to intake a note, which will pass it to an indexer, which passes it to a flywheel or shooter. Perhaps the indexer phase is bypassable. That is up to be decided later. So till now, what we've had is, if you look on the CAD channel, you'll see that we tested with the old design, but the dimensions are the same as this new design that's supposed to be the stationary ground intake, where we have a 0.25-inch compression between these two rollers, and they grip the note well enough, even without any grip tape on the tubes. They suck the note in, and they'll pass it on. So in this region over here, hopefully you can see my mouse moving, is going to be where the belly pan and the robot, like the servo module in this corner and this corner, and this is external. So perhaps the bumper can be reinforced by this max tube that I've just inserted here. So note goes in and it gets passed to something else, which hasn't been fully decided yet. This is the mechanism. Of course, like in the CAD channel, we were discussing whether two sets of rollers are needed or just one set of rollers. Those are all the specifics to be hashed out later. The main strategy here is that we have finalized on this under bumper concept, and hopefully we can refine some of these details as we have more of the robot decided. Does anyone have any questions on this design or the general intake concepts?
Yeah, so with this, I'm pretty sure we already confirmed that our intake is gonna extend our drivetrain. So do you have maybe a length or an estimate of how much this is gonna add to our drivetrain?
Good question. Currently in this configuration right now, it extends 7 inches, which means from this line to this line. But of course, it can be reduced based on what angle we want this path to go up, and also based on how many rollers are actually needed, right? Imagine if these two rollers were deleted, then the size almost cuts in half. So it depends on all of these things, but if you just go by how the design is right now, it's 7 inches from these two blue lines. Any other question?
Okay, sorry. How does this? So this mounts to the rails that are holding onto the swerve drive on the sides, right? Is that how this mounts into the? I'm
Yes.
just asking how this mounts onto the drivetrain.
You're absolutely right. So this extension here, you can see this rectangle just sticking out randomly. This one will hopefully screw into the sides of our rev swerve. So it'll be a slight thickness outside of that frame perimeter, but it shouldn't be a big problem. There's alternative ways to put it too. Like once I have the dimensions of the 1x1 that's supposed to circle our drive base, hopefully Cedric can talk about that later. I'll also integrate holes for that where it can attach to the 1x1.
Another question, I guess, is one of the points Carl brought up. For bearing retention, you said that you've catted in like the screw holes and stuff. Yeah. And I feel like that works, but there's also like a significantly cleaner way to do it with the dead axle system, where you run like a dead axle across and then you have the whole tube spinning with a pulley and bearing.
Correct, yeah.
What do you think about like integrating that? Because then it reduces the number of moving parts on the outside of the frame perimeter.
I think it can be done. We just have to test and explore it. The reason I did this one right now is because if we want to prototype this and make it on Tuesday at Lamar, it can be done right away because we have all the parts. But I mean, in the end, the functionality is the same, right?
Yeah.
Cool.
Why do you have the motor so high? Why can't we put the motor like lower down?
Well, there's not much space in other regions. Like if I put it in this area, for example, it's just not thick enough. The motor holes get in the way. I didn't want to put it down just because it's hard to access if we ever want to repair or replace anything. I felt like this was an ideal spot. And actually, this whole height is 15 inches. So I don't believe it's that high. It might look tall, but it's not that much. If needed, it can be changed. But also the distance is very nice for pulleys and like pulleys connecting to these shafts.
I feel like once we have like a full robot, like with the indexer mechanism attached to it, it'll be significantly easier to change the location of the motor, because I'm assuming that the intake motor will also power the rollers inside the frame perimeter to a certain extent. So we can use like belts and pulleys for that.
Yeah,
and we'll move it.
It'll be fine for just a test, just to run a real motor. We mess with the Versa that we have. Neo. It seems like Spectrum's running on this direct like Neo. So I think this will be a good way to test stuff out. We do have to build more rollers, though. I don't know.
Yeah, that's fine. Currently for the motor, you can also see it's inset into the drive, so it's not going to get hit. You can imagine there's 5 inches of bumper ahead of this, plus 1 inch of max tube, and then plus 1 inch of inset. So I don't think it's weak. I think it's just very easily accessible. That's why I like it. And the center of gravity is not that much negative by it, because it's only 15 inches.
Yeah, I think we'll learn a lot from just laser cutting something like this and testing with rollers. Make sure we get all the belts and gears set up right.
Yeah.
Cool. We want to move on to drivetrain unless somebody else has to talk about here. Let's do it. Drivetrain. Cedric.
Yeah, I'm gonna share my screen here. Okay, so can you guys see the screen? Yeah, can you guys see the screen? Is this?
Yes.
So this, like we talked about, this is 24 by 24, just standard tube for the main drive rails with a 1x1 skirt, 2.5 inches above the drive rail. I think one of the things we changed was, I think before we had the idea of stacking the 2x1s, but I realized that really wasn't needed. So instead we're using gussets just to keep, the only reason we use this is to prevent the note from getting under the drivetrain and like possibly getting into swerve wheels. And so yeah, that was our solution to that. And then we decided that the bracing was going to be side to side instead of front to back. We thought that would leave more space for electronics, even though it may make mounting subsystems a little bit more difficult. And then one of the biggest changes was the way we're going to mount the battery. So originally, from the thing that we printed yesterday, the idea was that a strap. The battery would fit in, and the strap would go underneath the belly pan and loop around to. It's like a ratchet strap to strap it down. But with this design, I tried to use, I think, Andy Mark's Velcro battery strap. So the battery would sit here, and there'd be Velcro here with strap retention on this side to Velcro the battery down. And it worked out in such a way that the geometry lined up, and instead of using standoffs and screwing the standoffs in, we can just screw the motor mount straight into the bracing. And then I think the thing that is missing from here is just electronics, which, I mean, haven't gotten to quite yet, is that and spark maxes. But other than that, that's basically what I've been up to for the past 2 days. So, yeah.
I have one question.
Yes.
Yeah.
So these plastic plates you put on the side, does that give us the risk of, for example, if I'm just remembering from my Vex robotics competitions, when we put plastic plates on the side, there's always a chance that if the robot tips slightly, then we can kind of get stuck with a note under that plate. What if we just printed some type of cover around the swerve module so that they don't get stuck in the wheels and leave our belly pan to have it clear?
So this was actually something we talked about on Saturday with Mr. Chris. And what we were originally thinking was have the belly pan super low to the ground. But eventually we decided that it just came with more logistical challenges than we thought would help, like the benefits from it. And like you said, we brought up the idea of like getting stuck on notes and whatnot on the field. And we said that if in testing, like it becomes clear that we need to add like some sort of guide or guard underneath our belly pan, we can always just stick some angle bracket underneath our belly pan and then stick a thin sheet of polycarb down there. But having our belly pan a little bit higher would allow us to have just like less work on the drivetrain and just be a bit easier for us to like work on for real.
Yeah, no, I like the belly pan being high as well. I don't think it needs to go down. What I'm saying is that this rev swerve gives you 2.75 inches of clearance. So technically, if you had nothing, not even the plastic sheets, you could completely drive over a note and you would be fine. So the only risk here is having a note getting stuck in your wheels, not at the bottom of your robot. So if you had something to print, 3D print just around the wheels, you won't even risk being stuck on a note with the plastic, right? Because you won't still wedge on a note.
You won't ever like have your wheel stuck on a note, right? Like it might wedge in there, but the idea is like your wheel will end up inside of the note is what we're trying to avoid, because the note is like a torus.
Mm-hmm. Right? I think what Tom was trying to say is he's concerned that our robot tips a little bit, the note gets stuck where such that this thin plastic sheet goes in between one of the notes, right?
Exactly.
So
yes.
Where it gets stuck, that get pulled upwards, right?
Mm-hmm.
And the thing is, I think that from what we've seen online, as the note is so it glides so on the ground that even minor contact by something like a little piece of plastic will push it around the field. From what we've seen, as long as it doesn't attempt to essentially climb onto the note, it doesn't really. The notes get pushed around. That's why intakes. I think we have to be really grippy on the intake this year. I think,
okay,
especially if we're pushing something into it. You know, I understand your concern, and we'll probably have to test that.
Yeah.
At the end of the day. That's just something you have to test.
Mm-hmm.
Yeah, but there is like a simple solution if we find that this is a problem in testing.
Yeah.
All right then. Sounds
also,
good.
I think your intake plates. It might be a good. It might be an idea to either it might be good to either lengthen the skirt and then integrate the skirt with your intake plates, or maybe lengthen the skirt and have your intake plates connect to the polycarb.
Yeah, and you can always, I'm pretty sure, you can probably mount, you can probably use a skirt as a face to mount their intake plate. I mean, I don't know how strong that'll be, but I mean, it's an option you can use, and then have a motor slightly below that.
I think you guys need to get some of those into.
Yeah.
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 You need to start. If you touch with, it's fine, but actually, I think it's gonna have to be. So you guys just take start.
Yeah.
I think integrating the intake plate and the skirt looks like a good plan. All in one
I
piece.
think somehow just hand off what you have. And that's fine. Final measurements. Drivetrain. Change those dimensions.
Sounds good.
Do you guys have standoffs here on this bumper rail? Is that
Yeah, so the skirt, originally we had 2-inch rev standoffs, but we tried. But when I tried to mount it, I mean it didn't really have interference, but it was basically flush. The height of this was basically flush with the Neo, and we thought that was a bit too close for comfort. So these are WCP 2.5-inch standoffs, which I don't know if we have those, but
They're just tapped Thunder Hex. So. Yeah.
yeah, probably.
Mm-hmm.
there's a lot of
Okay.
Yeah.
And then the battery strap, I don't know if apparently Greg said we have one at Lamar
We know West Side.
West Side.
We have a
but
couple at West Side.
It was
Can you open the website for it?
it's right here. Alright, let me stop and share again. Yeah, so this is the idea. Oh, this is what I'm thinking of using to strap the battery down.
yeah, this is pretty much certainly
Yeah. Okay.
You guys have anything else you want to share on
Can we take one last look at that real quick?
Oh yeah. On the battery strap or on the
The standoff. So I'd like to make a comment.
Okay.
Just curious, how are you planning to connect those three pieces together? Top rail, standoff, drivetrain rail.
Long screws.
On
Yeah.
screws, yeah. I'm not quite a fan of that. I was going to suggest, can we use more pieces of 1x1 stood on their ends vertically and then T-gussets to connect them? Do we have space to do something like that?
Yeah, we should, yeah.
We'll have to modify that out. Actually, no, that should fit. Yeah.
Well, something to consider. I think we're going to have a lot of loose and bent bolts in our future because that's...
Maybe that's probably.
Yeah.
Write that down.
Yeah.
I want to hide a little bit of stuff too. So it takes a little bit of more.
definitely.
We have
You can also rivet that.
Probably will have to do with that.
Yeah. Okay.
look at some other teams. Now,
Yeah.
felt the win.
Or even I think like for example in this in this where these four standoffs are, you could probably just use more 2x1 and then put a gusset on it. Maybe, I don't know.
Yeah, so that's what we're talking about. The upper rail itself is a 1 inch by 1 inch.
Yes.
square feet. So we're placing the standoff it's like circular, it's just more of this 1 inch by 1 inch square feet.
Mhm.
So that's what we end up doing.
Yeah. I got it.
Let's, in the interest of time, we'll get to the